Welcome to our explainer. You know, there's something we do literally every second of our waking lives that we almost never think about, and that's seeing. Today, we're going to pull back the curtain on the incredible, kind of mind bending physics behind it. We're talking about light and its wild journey from the quantum world straight to you. All right, first up, lighting up our world. And really, it's about more than just seeing in the dark. I mean, light is so fundamental, right? It's just there. And because it's always there, it's so easy to forget how much we completely depend on it to just exist and move around. Yeah, on the surface, it's pretty simple. Light helps us see stuff. It lets us tell a coffee mug from a donut, figure out their shapes, their colors, not walk into walls. Super useful. But what's really cool is that behind this super simple act is a whole universe of some seriously fascinating science. And think about it, light comes from all over the place. We've got the sun, which is basically this giant nuclear reactor in the sky. Then there's the light bulb, which is all about electricity. You've got a candle flame or even a firefly, which is pure chemistry. And heck, even a piece of iron will glow if you get it hot enough. So many different sources. So, what's the deal? What do all these completely different things have in common? A star, a bug, and a hot piece of metal? What's the one thing that connects them all and lets them create light? It all comes down to one word: energy. That's it. Energy is like the engine of the entire universe. I love how the source material puts it. It's what makes our universe the happening place it is. Nothing happens, absolutely nothing, without energy. Okay, so if it's all about energy, let's follow the trail. Where does most of the energy here on Earth really come from? Well, let's trace it back to the ultimate source. And surprise, surprise, it's the sun. Just about everything on our planet is powered by the sun, either directly or indirectly. The food you eat, that's stored solar energy from plants. The wind that powers a turbine, that's driven by solar energy heating the atmosphere. It's all one big connected system, all starting from our star. This is where it gets really mind-blowing. Think about fossil fuels: coal, gas, oil. When we burn them for energy, what are we really doing? We're releasing sunlight. Yeah, sunlight that was captured by plants millions of years ago, got buried, and turned into fuel. You're literally using ancient, bottled-up sunshine to power your car. How wild is that? Okay, so light is energy, and it comes from the sun. Got it. But what is light itself? I mean, how does this energy get from way out there all the way to us through the vacuum of space? This simple question led to one of the biggest, most epic debates in the history of physics. So you had two camps. In one corner, you had Team Wave. They had experiments showing light spreads out, bends around corners. It acts just like a wave in water. Makes sense. But in the other corner, you had Team Particle. Their experiments showed light acting like a stream of tiny individual packets of stuff, almost like microscopic bullets. And they had good evidence too. So which one is it? A wave or a particle? Because it can't be both, right? I mean, a wave is spread out. It's a disturbance. A particle is a tiny little thing in one place. They're total opposites. This was a massive headache for physicists for a long, long time. And the solution, when it finally came, didn't involve picking a winner. Instead, it blew the doors off physics as we knew it and gave us something totally new: quantum mechanics. And it all starts with this one little character: the photon. So the photon is the fundamental particle of light. It's a tiny little packet, a quantum of energy. But here's where things get weird right away. A photon has energy, you can measure it, but it has zero mass, no weight at all. Think about that. It's pure energy just zipping through space. And because it has no mass, it can do something nothing else can. It travels at the ultimate cosmic speed limit, what we call the speed of light. We're talking 299,792 kilometers per second. That's fast enough to go around the Earth more than 7 times in a single second. And only massless things like photons can hit that speed. But here's a fun little twist. That top speed, that's only in a total vacuum, like in deep space. The moment a photon passes through something like air, water, or a pane of glass, it actually slows down. So yeah, the light coming through your window right now is literally moving slower than the light just outside it. Kinda cool, right? So, we have our particle, the photon. That settles it, right? Light is a particle. Well, not so fast. Discovering the photon didn't end the debate. Oh no, it actually just cranked up the weirdness to a whole new level. And this, right here, is the absolute heart of quantum mechanics. It turns out light isn't a wave or a particle. It's both at the same time. This is called wave-particle duality, and it's as bizarre as it sounds. If you set up an experiment to look for a wave, light behaves like a wave. If you set up an experiment to find a particle, it behaves like a particle. It's almost like it knows what you're looking for. So let's bring this all the way back home. How do you see? Well, it's all because of this quantum craziness. Trillions of photons are flying from a light source, bouncing off everything around you, and then hitting your eye. They travel through space with wave-like properties, but when they hit your retina, they arrive as distinct particles, one by one. Just stop and think about that for a second. The simple act of looking at something means your brain is interpreting this constant, massive stream of tiny, massless energy packets that have bounced off the world. Every time you open your eyes, you are personally participating in a quantum mechanical event. Seeing isn't like quantum physics, it is quantum physics in action. And that just leaves you wondering, doesn't it? The journey to understand something as simple and everyday as light ended up completely rewriting the rules of reality itself. So what other huge secrets about the universe are hiding right in front of us, in things we see every day, just waiting for us to get curious?